All right, let's go ahead and get started. Welcome to episode 7 of the Home and Energy Chats webinar series. Tonight we are focusing on what is a pretty good house. My name is Heather Chandler and I'm the owner and publisher of Green and Healthy Maine Homes. We have a great lineup tonight with the team who are literally writing the book on the pretty good house concept, and it promises to be a great presentation and discussion. So thank you for joining us. I would like to start by sharing a special thank you to our sponsors, including our presenting sponsor for this year's Home and Energy Chats, Royal River Heat Pumps. Specializing in the comfort and efficiency of your home, Royal River Heat Pumps offers the highest quality electric heat pump installation and service in Maine. Call for a no-cost site visit with one of their design experts or check them out online at royalriverheatpumps.com. I would also like to thank our season sponsors, Bath Savings, a local Maine bank that proudly invests in the people, places, and businesses that make Maine strong. Bath Savings, your neighbor, your bank. And Senecal Construction Services, now offering net zero ready design build packages in Pownell, conveniently located just minutes from Portland, Freeport, and Brunswick. So thank you to all of our Home and Energy Chat sponsors. A quick overview of the evening. We will begin with a presentation from our panelists and a case study, and then we are going to open it up to discussion with Q&A led by our moderator, Dan Kolbert. So please submit any questions you have for our panelists using the Q&A feature at the bottom of your screen, and we will do our best to get to all of them. I will say that we had quite a few come in through the registration process, so we may not be able to get to all of them, but we will do our best. And a reminder that the webinar is being recorded and we will be uploading it to our website, greenmainehomes.com, later this week. If you are not familiar with us, Green and Healthy Maine Homes is a multimedia brand dedicated to inspiring healthy, sustainable, energy smart, and future-ready Maine homes through a biannual print magazine, an online business directory, monthly email newsletters, and an active social media presence. We share expert advice to inspire healthy, comfortable, affordable, efficient, and sustainable Maine homes. So check us out at greenmainehomes.com to learn more. And now it is my honor to introduce our panelists and moderator for the evening. Michael Maines earned a degree in structural engineering and since 2008 has focused on designing homes and renovations. He wrote the Green Building Advisor blog post that announced the Pretty Good House to the world and is a contributing editor at Fine Home Building, a certified passive house consultant and co-founder of the BS and Beer Show, a weekly building science show for professionals and civilians alike. Emily Mottram is the founder and principal of Mottram Architecture. Emily also teaches building science and sustainable design at a local community college and has served as a consultant for projects in a secondary school trade program. She hosts the weekly podcast E3, which is Energy and Efficiency with Emily, and also co-hosts the BS and Beer Show. And last but not least, Dan Kolbert is a contractor in Portland. He is the moderator of the Building Science Discussion Group, where the Pretty Good House concept was born. And all three of our guests this evening are co-writing a new book, the Pretty Good House book, which, along with Chris Briley, who could not be with us tonight, and that book is expected to be released next spring. And all three also serve on the advisory board of the Green and Healthy Maine Homes and are nationally respected builders and designers. And so we are very fortunate to have them join us this evening. So thank you all for being here. At this point, I would like to turn it over to Mike, who's going to kick off the presentation.
Thank you very much, Heather. Yeah, so Chris couldn't make it tonight, but this is the Pretty Good House book team, and we'll be starting tonight. I'll give sort of an overview and history and sort of some broad rules of what the Pretty Good House means. And then Dan will go into more of the specifics as to what it means for for your actual house. And Emily will wrap up with a case study explaining how a project of hers meets pretty good house philosophy. So next. And if you want more information after tonight, check out our website, prettygoodhouse.org. We have sort of brief overviews of the main points that Dan will be talking about. And over time, we intend to add additional information to the website. Next. So this whole thing started, we call it Dan's stupid idea. Dan hosted, or Dan was the moderator, or is the moderator at a monthly discussion group at Performance Building Supply right in Portland for mainly professionals to get together to share building science knowledge. Building science is a relatively new field, and construction, there's a lot of complicated things to know in construction, and it's hard to get everybody on the same page. So Dan and Steve Constantino, who owns Performance Building Supply, started doing this monthly get together 12 or 13 years ago, and it was great. We talked about things from vented roofs to foundation waterproofing and all kinds of exciting topics. After a couple of years of that, one night Dan came in. He had been working on, I believe it was his second LEED certified house. The passive house program was sort of gaining steam, which can include pretty ridiculous amounts of insulation. And Dan basically just said, like, these programs all have good points, but they're complicated. They can be gamed. They're not really doing necessarily what they're meant to do. What should we all be doing instead? What would a pretty good house look like? And we brainstormed ideas over a couple of sessions. And as Heather said, I wrote it up as a blog post for greenbuildingadvisor.com, which is a really good website for building science related things. And 10 years later, the idea still is around. So we decided to write a book about it. Next. When I moved away from Portland, I missed that monthly get together. So I started my own at a local brewery, and that was fun. Then COVID hit, and Emily and I took it to Zoom. So now Emily and I and Kylie and Travis have a weekly show similar to the discussion group in Portland, where we just basically sit around and chat and drink beer or tea or whatever and talk about building science topics. So that's just a shameless plug, but it wouldn't have happened without the Portland discussion group, same as Pretty Good House wouldn't have happened without the Portland discussion group. Next. So why do we need Pretty Good House? We have a building code that Maine is currently on, mostly on the 2015 International Residential Code. International is a bit grandiose. It's really only used in the US as far as I know, but anyway, it's a pretty comprehensive set of rules on how to build a house safely and insulate it reasonably well and things like that. So it's a good baseline, but it's also technically the worst house you can legally build. Plenty of houses don't even meet code minimum standards. Very few existing houses meet the current code minimum standard, but just it's an okay house. It's not a good house. At the other end of the spectrum, we have things like LEED for homes, leadership in energy efficient design. We have passive house, both the international and the US offshoot. We have the Living Building Challenge, which is really pushing the envelope. It's a really stringent, really great program, really challenging, so challenging that in 20 years, exactly 2 homes in the US have met the standard. So while those of us in the industry admire it and want to do more, it's not exactly changing the vast majority of housing stock. In between all those, we need, the niche the Pretty Good House fills is sort of in between code minimum and these sort of stretch programs that may or may not actually make sense. Next. So what is the pretty good house? Next. This is it's a drawn out phrase, but it sums things up pretty well. The pretty good house approach is a framework to guide focus toward the core issues that should be front and center when designing and building a high quality home or renovation. And I promise this will not be one of those presentations where we just read the slides. Next. So before we get into sort of the house specific things, these are just sort of, these are things every pretty good house should have. And really, these are things every house should have or consider, or just these are the important things that may not be what you're thinking about when considering designing and building a house. Next. So the first is consider the house as a system. Your car is composed of a lot of different parts that all work and interrelate together. The ecosystems are complicated, and with those sort of complicated things, we understand sort of intuitively that if we change one thing, it affects something else. With homes, people often don't realize how important or how much of a system a house actually is. How much sun comes into the house, is dependent on what your window system is, and that affects your comfort, and the building envelope is involved. And then we have moisture concerns, and sort of, unfortunately, the better performing the house, the more sensitive it is to changes. It doesn't mean we shouldn't be building good houses. It just means that it's a little more complicated than the way we built 100 years ago. Next. A core part of the pretty good house is to build no larger than necessary. In a pretty good house, we sort of brainstorm these ideas. These are not hard and fast rules. These are targets. With COVID and people working from home and schooling from home, these may be on the small side, but it's still good to think of these as a crowdsourced range of good sizes. So a home that's just for one person might be in the 600 to 1,000 foot range. For two people, 800 to 1,500 square feet. For three people, up to 1,750. For four people, up to 1,900 or so. So the national average occupancy is about 2.5 people. So if you do the math in a pretty good house, that means a pretty good house for 2.5 people would be 1,600 square feet. I don't know where the half person comes in, but that's what the math says. The U.S. national average is somewhere between 26 and 2,700, or between 25 and 2,700 square feet. It's come down a little bit in the last couple of years, but anyway, the national average house is significantly bigger than it needs to be, and that's for things like living rooms that don't get used, and spare bedrooms that don't get used, and just lots of space, just extra space that isn't necessary. Next. Similar looking slide, but based on a per person basis. In the pretty good house, we're basically saying one person needs X amount of space. Each additional person doesn't need that same amount of space. You don't need an extra kitchen for each person. You don't need an extra bathroom for each person, an extra dining room. So for each additional person, you get less and less additional square footage. Next. With a pretty good house should be built simply. On the top is the Joshua Bodwell house in Hollowell. It's actually owned by a friend of mine, and I've designed a carriage house for it. It's a beautiful house, well built, well maintained, well insulated now. It never was in the past. But part of that maintenance is basically every year the owner redoes one facade, and by the time he's back around to the front, it's time to scrape and paint and repair and do it all over again. So while he enjoys it, most of us do not enjoy that level of maintenance. On the bottom is a nice, simple house designed by Emily. It's low maintenance, it's comfortable, still built with mostly natural materials. Just that's. On the bottom is a pretty good house. On the top is just a nice house. Next. As far as I know, of all the sort of stretch programs out there and the building codes, I've never heard of any other program that even talks about what things cost. And in 30 years of working in construction and design, I've never had a project where cost wasn't a primary concern. So, so a big part of the Pretty Good House is to basically make energy improvements until they stop making sense. Exactly where that point is not a hard and fast point the way it is with like the Passive House program. It's certainly above code minimum. It can be as good as Passive House if it makes financial sense, if it meets the goals. Usually a Pretty Good House will be somewhere in between code minimum and a Passive House level. Next. Prioritize a Pretty Good House should prioritize good indoor air quality. This is certainly on everybody's mind due to the pandemic, but even without the pandemic, we should always be ventilating our cooking surfaces, and not just gas stoves. Every cooktop in a kitchen should have a range hood, and the range hood should be used because cooking just puts a lot of particulate matters into the air that are really bad for your health. I love a nice steamy shower. Your house doesn't. You want to get that moisture out of the house as quickly as possible. On the bottom is a mechanical balanced ventilation system, so it brings in clean, fresh, filtered outdoor air. It can be filtered up to HEPA levels. And the air is preconditioned with the outgoing air, so it's like a little radiator that ventilates the entire house. Next. So although modern life, we often are buying vegetables grown in Australia and cooking on things built in China, and just it's very much a global economy. But when you're building a house, it's a lot of big, heavy stuff that can be purchased locally, can be created locally. So basically, support a local economy by shopping for your things there, and then also support the economy by building near village centers. We don't need more houses contributing to sprawl. We need to concentrate where we live. For efficiency and to preserve preserve habitats. Next slide. A Pretty Good House should support local and global ecosystems. This means a few different things. At the top is a chart you may have seen before. There are various ways to break it down. Some people criticize this particular breakdown. It doesn't matter. The point is, buildings contribute a lot to global warming, greenhouse gas emissions, both in operation. So that's the energy or the carbon emissions emitted in heating and cooling and those kinds of things. But also embodied carbon is basically the pollution created, creating the things that go into the house. So on day one, when you move into the house, you've already used up your embodied carbon budget, and over the course of 100 years, the chart at the bottom shows that over the course of 100 years, operating carbon usually dwarfs embodied carbon in terms of importance. Next slide. But with the climate crisis, we don't have 100 years to make that up. So in the course of the next 10 years, which is literally what we have to worry about, embodied carbon is a much bigger deal than carbon emissions. So although it may be counterintuitive, it doesn't make sense to put a lot of high carbon, say, insulation into a house because although that will save energy for the next 100 years, it costs a lot of carbon emissions right now, and right now is what we have to worry about. Next slide. Supporting local and global ecosystems. Of course, we're all concerned about the polar bears. On the bottom is just a typical Maine lake. We have lots of lakes, and so pollution affects lakes, things like that. Just think about the externalities of your decisions. Next slide. A pretty good house should be durable and resilient. You know, with climate change, we have increasing floods, we have wildfires, but we also just have boring things like indoor moisture and things like that. So there are a lot of ways houses can be damaged, and so you want to build in a way that it won't be damaged. That doesn't mean build with lots and lots of plastic. You can, but a lot of times homes built with more natural materials are actually more resilient in the face of catastrophes. Next slide. And this one is surprisingly important. Design homes with aesthetic appeal. A house that is beautiful will be loved. A house that is ugly will not be loved. What beauty is, to some degree, is in the eye of the beholder. This is a new but traditional looking house designed by Robert Swinburne in Vermont. Next slide. It can be a modern house, such as this one, also by Bob Swinburne. Next slide, which are both pretty good houses, by the way. A traditional modern house by Emily. Next slide. And then a modern house by Chris Briley. So all different looks, but all pretty good in their own way. Next slide. And then I will turn it over to Dan to talk about Pretty Good House Guideposts.
Thanks, Mike. So Mike has been talking about, the general guidelines to what we're looking for. So how do we get there? So one of the things about Pretty Good House is, as Mike said, we really didn't want it to be prescriptive, meaning we didn't want to say, do this and this and this, and you've succeeded. We really wanted it to be more like a decision tree, so one example is, one of the things we decided to do in the book is at the end of every chapter, we have sort of a list of things. Have you considered X, Y, and Z? And we're not saying this is the right answer to those questions, but what we are saying is you need to have an answer to these questions. You need to have thought about these issues and come up with a solution. Your solution is your business, but if you don't have a solution to this question, then it could mean trouble. Next, please, Rain. So these actually turned out to be kind of the way we structured the book in terms of chapters. We will go through them. Next, please. This is a graph sort of showing the steps from start to finish, right? And in some ways, this is not really, this is a little too pat, right? Because I wish we could say that it was a linear process. In some ways, it's sort of like concentric circles that intersect at various points, because a lot of this stuff feeds back in. Some of the things like, your environmental control layers you may need very early in the process, or you're going to screw up your architectural design, for instance. But the idea is you need to start, you need to sort of go through these steps and factor them all in. Next, please. Yeah, this is making next. Oh, am I getting an echo here? I'm hearing an echo on my end. My apologies. So this is a graphic that Bob, who is in the audience, developed for our website, which is an excellent resource. It basically takes you through these, I don't know how well people can see it on their screens, but it was an attempt to sort of come up with a process map for the design and build process. And again, it's lineal, which may or may not be the way it actually goes, but it talks about all the various issues involved at each step. And again, this is, I think, at the very beginning of our website. So if you want to see it and spend more time on it, it's just prettygoodhouse.org. Next, please. So first up is economics. As Mike said, we're really trying to make this a we're trying to have money be front and center in everything we do, because we know in some ways not thinking about money is a good way to avoid making some important decisions. So this is really sort of showing, this could also be, if you flip this over, this would actually be the same graph showing the value of insulation, right? The first inch of insulation you put in does a huge amount of work. The second inch does less, third less, blah, blah, blah. So it's sort of the same calculus curve, except it's approaching zero instead of flattening out at the top. But the idea is the same, right? That as you make improvements, your incremental improvements may have less of an impact on the house itself. Some of them are very important. And again, where you draw your vertical line and say, I'm stopping, is up to you. It's part of it is budget related again. Part of it is climate related. It's a different, Pretty Good House is going to look very different in Maine than in Florida. And this is not just insulation we're talking about, it's all sorts of things. It's air quality issues, quality of windows, all of these things. But we want to make sure that money is one of the dials that we have to turn, and we want to make sure we are consciously doing it. Next, please. The team is critically important, especially for the economics piece, but really for all of them. The three-legged stool model is design, client, who is also the source of the money, and the construction side. You need to have all three working together. And the best way to do that is to have all three involved from very early in the process. It doesn't matter if you as the client pick your designer first or your contractor first, but we certainly recommend that you have both in place early in the design process. This brings up the whole question of competitive bidding, which we can talk about later if we want, but we would recommend that having your contractor picked up front is a much better way to save money than putting the project out to competitive bidding. And it also is a much better way to make sure that your house is actually getting built the way it's been designed. If the contractor is actually part of the design process and can say, no, we can't do it this way, or here's a way to get the same result a lot cheaper, or, if you're facing two options that you can't decide between, this one is going to cost a lot more money than that one. Next, please. So again, here's the graph that Mike showed earlier. This is the current climate map of the U.S. You can see, obviously, as you get farther north, heating is more important than cooling. Maine is in zone 6. All of the U.S. is in from zone 1 to zone 7. Maine is zone 6, except for Aroostook County, which is zone 7. There are, I think it's already underway. They haven't released anything, but obviously the climate maps are going to change, and they're probably going to change quickly and continuously. So our assumptions about how we build need to factor in what we do know. We don't know everything about what the next period is going to look like, but we do know that, as Mike said, storms, obviously hotter weather, more dramatic weather, and flooding in Maine. We'll see how much fires are an issue here. Next, please. So regulation verification. Regulation just refers to the building code and anything else. There's the building code, there's the energy code, there's fire code issues. Those you have to meet. Although obviously, especially in Maine, enforcement is often iffy. Verification, though, as a whole, is a voluntary thing, but we think is much more important even than code. What verification refers to is once you've built the house, making sure it actually performs to design. The picture that you see is of a blower door. This is a very important tool both for diagnostics and for verification. what it does is it tests the air tightness of your house by pressurizing the house or depressurizing it, excuse me, and then comparing and then seeing how much air is escaping while you're doing that. That's one of the most important ways to do it. One of the most important verification tools. There are other things too. There are infrared cameras, which can help see where heat's leaking out. There are things called flow hoods, which test if fans are moving as much air as they're supposed to. There are, and then there's some simple things like just, monitoring your energy consumption. Is it using as much energy as the energy model predicted it would? So verification is critically important. It's actually made its way into the code in the sense of the energy code requires a certain level of air tightness, and it requires that you actually have a blower door test done. Next, please. Owner occupant influence. We often joke that we can build that our houses would be perfect if people didn't insist on moving into them. It's obviously huge. We, Chris Briley, our co-author, and I built a house years ago, and for some clients who insisted on radiant floors, which are very nice, but as many of you know, I'm sure they're very slow. They respond very slowly, and they operate best at just setting the temperature and leaving it alone. What we didn't find out till the clients moved in was that the couple, they slept in separate bedrooms. One of them liked a warm bedroom, the other one liked a really cold bedroom. And so the only way for him to get that was to leave the windows open every night, even in the dead of winter. That simple piece of information would have made a big difference in our design. Other things just like choice of appliances, some monster TVs use obscene amounts of electricity, making sure all of your appliances are Energy Star rated at a minimum, all of these things. And then also making sure that you as the owner understand how your house is supposed to operate. And that, frankly, is the responsibility of the contractor and to a lesser extent, the designer. One of the things we recommend, and that I think all of us do as practitioners, is that the client has an owner's manual. In some ways, it's kind of malpractice to think about spending, hundreds of thousands of dollars, up to $1 million for a house, and the client just says, and the contractor hands over the keys and says, "Good luck to you," with absolutely no effort made to educate you. Even things like, what is the schedule for replacing the filters in your ventilation system? But homeowner education needs to be a part of this, or there's just no way the house is going to perform well. Next, please. So those were kind of what happens in the background, kind of, and then this is more about the construction side of things. The first is architectural design, which starts, as you see on the right, that's a site plan. The architectural design really starts with the site. You may already have a site. If you don't, it's certainly not a bad idea to bring in either an architectural designer or a landscape designer to check out a site you're looking at for things that you may not think about, like solar exposure, both for passive solar and for renewables, drainage, site drainage. Is this a site that's going to hold water and cause problems, or is it something where you can get water away from the house? Trees, soil, ledge, all of those things. And then obviously the house itself, and I assume I don't need to go into the importance of that. Next, please. So then we get into the environmental control layers. And this way of describing things is relatively recent. We've gone through a lot of terminology over the years, but we've sort of narrowed it down to these 4 different things that need to be controlled. And it's important to say up front that there are 4 things we're looking at, and it doesn't mean there are 4 different layers. There could just be, there could conceivably be one layer that's doing all 4 of these. We certainly often combine at least 2 layers in one. But anyway, quickly going through them, there's the water control layer, which is often referred to as the weather resistant barrier, which we used to call the house wrap, things like Tyvek. The first layer that goes over the plywood, basically. Then there's the air control layer, and that can be in any number of places. But the idea here is that we want the house to be airtight to the greatest extent possible. And the way to do that is to have a continuous air barrier at some point in the house. We often talk about the visual model for this is that if you take a cross section of the house, can you trace your air barrier from the foundation on one side up over the roof back down to the foundation on the other side without taking your pen off the paper? That shows that you've got continuity of the air barrier, and that air is not going to leak out where you make a transition that's not detailed well. The vapor control layer. This is definitely, in some ways, the most complicated and tricky one. You may not want a vapor control layer at all. There's something called vapor open, which basically means that vapor is free to go from one side, from the inside to the outside, and from the outside to the inside. The vapor control layer, in some ways, is the most climate specific one of these layers. Vapor drive is going to go, as with any other thing, from greater vapor, meaning greater humidity, to lesser, meaning drier. So, for instance, in Maine, in the summer, your vapor drive presumably is going to be from outside where it's hot and humid to the inside, especially if you have air conditioning, where it's cooler and drier. In the winter, it's going to be the opposite. The vapor drive will be from the inside to the outside. So in Maine, you probably want to make sure that things can move in both directions. In Florida, where you're probably going to be cooling all year round, the vapor drive presumably is only going to be in one direction, and having a vapor barrier, a strong vapor barrier, makes more sense. Similarly, also, if you're very far north, Alaska or whatever, where the winters are severe and the summers are not, it's also there. The thermal control layer is just a fancy way of saying the insulation, although it also includes doors and windows. So some examples: the water control layer is any kind of house wrap. It's typically doing that job. These days, we often, as in the picture on the top left, zip system. If any of you have driven around a job site, this green plywood is ubiquitous. It's a good product that basically has a coating on it, so you don't even need a house wrap. And this is an example of something that combines 2 layers, because the way you get it weather tight is that you tape. There's a proprietary tape that you tape your seams with on the sheathing, the green sheathing. This is also a really easy way to get an air control layer. Just using zip system will give you a reasonably airtight house all on its own. It is actually also an okay vapor control layer. And even the Zip is actually now making a product called Zip R, which is the same sheathing with a layer of foam insulation glued to the inside of it. So that's a product that's conceivably all 4 of these. But typically, as if you look at some of these other examples, you'll see, like in the bottom left, that looks like either plywood or OSB, and then it's got a membrane over the top of it, a house wrap of some sort, and then the siding on top of it. One thing you'll see in, I guess, at least 3 of these pictures is a rain screen. That's these vertical slats, the strapping going vertically in the 3 pictures. That is a really important part of your vapor control layer. Well, not your vapor control layer, but your vapor control. What this does is it keeps the siding off of direct contact with your water control layer. And it does two things. One is when your siding gets saturated by the rain, it prevents that wet siding, whether it's wood or stucco or fiber cement or anything, from wicking that water into the building. And the other thing it does is it allows vapor drive from the interior to escape when it hits the outside, instead of condensing on the backside of the siding, where it will either at a minimum cause paint problems on the siding, and if you're really lucky, will cause your siding and sheathing to rot out. Next, please. Structures and finishes. It is, this is, I'm trying to think here. This is, one thing I will say about structure is, as Mike was saying before, simple shapes provide a lot of benefits. They certainly, on the economic front, they're cheaper to build. They're easier to maintain. Typically, a simple shape is easier to maintain, and perhaps most importantly, they're a lot easier to insulate. Anytime you need a beam, or a heavy piece of LVL or steel, that is basically space that would be better occupied by insulation. So engineering is the enemy, we say. And finishes, you want to make sure, non-toxic obviously is critically important. There's a lot of choices for finishes. And we are lucky now that we have much better information than we used to in terms of the content of a lot of these things. There are things called environmental content declarations. Somebody help me out here. Anyway, we can get back to that later, but more and more manufacturers are actually listing what is in their products, which makes life a lot easier for picking things. Next, please. Windows and doors. A decade ago, our choices were really not so great. There were a couple of Canadian manufacturers making pretty high performance windows, and then there were some European manufacturers. They were very expensive, hard to get your hands on, hadn't really been tested to US standards. So one of the great things that Passive House has done has been to dramatically improve the quality of windows and doors. The picture on the top right is of a triple glazed window with a thermally broken sash, meaning that the sash itself is providing a much better layer of insulation than a typical window would. This is one thing where energy modeling can really help you out. This is a question that often comes up in renovation, right? At what point does it make sense to use triple glazed windows if your house is never going to be that high performing in the first place? So energy modeling can really help you out there. As one of our colleagues always says, the best performing window is still a really crappy wall. The most you're going to get out of a window is maybe, R5 to R10, as opposed to, an R40 or greater wall. So to a certain extent, obviously, the most important thing is strategic use of windows and doors. It's also easy to get very uptight about them. They are still a relatively small percentage of your square footage of your exterior. But again, air sealing in some ways is even more important than R value, because you really don't want to draft. The window units also, we're lucky they have ratings that are much better than they used to be, and they tell you information like how well do they seal, what is their R value, although in this case it's called a U value. And one other thing that I'll just say quickly is, as you can see on the triple glazed window cutaway, it's not a double glazed window. None of these windows, I think, are, I mean, I'm sorry, not double glazed, double hung. More and more we are trying to get away from double hung windows, the old style that go up and down vertically, and are recommending people use either casements or tilt turns, which are windows that close solidly against a weather stripping and can really seal tightly. With double hung windows, because they have to slide up and down on their track, there's a limit to how tightly they can seal, because at a certain point they just won't be operable. All right, next, please. Materials. This is a huge topic that I will just briefly touch on, because we probably could have spent the whole thing just on materials. But questions like, where were they sourced, right? Even if it in itself is a low carbon material, if it has to be shipped halfway around the world, that is a big part of its embodied carbon. Is installing or living with them bad for your health? That's, I hope, fairly obvious. Are they durable and repairable? That is huge. And we can talk about that later, but, repairable means a lot of different things. Like with, masonry is very repairable, typically repointed every 50 to 100 years. What is their carbon footprint? This is a huge topic in and of itself. The calculations are very hard to do. It's sort of, for one thing, where do you start and where do you end? There is, do you start for a wood product, you start in the forest, do you start when it shows up at the sawmill, et cetera, et cetera. And also end of life is also one of the carbon footprint issues. Are they appropriate for the location? That's, well, again, I hope that's pretty obvious, but that is, we see a lot of things done that from things that may work here would not work so well in Florida, and vice versa. Next, please. Environmental controls refers to heating and cooling and ventilation mostly. We have a lot more resources for ventilation and for heating and cooling than we used to. The picture to the left shows a wall cassette for an air source heat pump. That is pretty much most people's go-to for heating and cooling. In Maine, it's only pretty recently that we started thinking about air conditioning. And that's one I would, a lot of us would have recommended air source heat pumps, even if they only did heating, but a perk is that they do both heating and cooling, which unfortunately is something that we are thinking about more. Below that is the Santa Fe. That's a dehumidification unit. Controlling humidity is a critically important part of a air sealed house. Trapping moisture is one of those very remarkably fast house killers. At a minimum, you're at risk of growing mold, and farther down the road, you get rot. The rest of these items, well, there's the Nest thermostats, but the other three, the Lunos, the Minotaur, and to the right is a Zender. Those are all variations on ventilation. They're all called balanced ventilation systems. Early on, before we were thinking so much about being airtight, but when we knew we wanted to do ventilation, we would often just wire up a house so the bath fan ran continuously at a low speed. That can still work, but once you get to a certain level of air tightness, you're going to have a hard time pulling in. If you think about a straw and you put your finger over it, you can't really draw it. You can't, you can form a vacuum, but you can't pull air through it. The same with a tight house. You can push air out through your fan, but at a certain point, if you're not drawing air in, it's not actually going to be moving any air. So these balanced ventilation units solve that problem by having both an input and an output. The problem there, of course, is that in the winter in Maine, you're pulling in cold, dry air and exhausting your already warmed, cooler, moister air. So these all have some way of transferring the heat from the intake. From the exhaust to the intake in Maine in the winter. It's obviously the opposite in Florida. But it's a way for them to be much more energy efficient. So you're not losing all that conditioned air and having to do it all over again with every time it turns on. Some of these are, I don't even remember, 90% or more efficient at transferring the heat energy from one side to the other. There are also units called, these are the ones that only do heat are called HRVs. There are other units called ERV, which stands for Energy Recovery Ventilator, which also is able to transfer some of the humidity from one side to the other too, which is very nice for like not drying out your house painfully in the dead of winter. Okay, next. Energy and lighting. So here we're talking about both energy consumption and energy production. I saw there was one question about balancing out energy efficiency and like PV. We would always recommend that you focus on energy efficiency first and then thinking about renewables. But we also would always recommend that your house be prepared for PV if possible. PV being photovoltaic, the panels on the lower picture. But in terms of reducing consumption, on the left you see an LED light. That's a no-brainer and is pretty universal these days. But really, at a certain point, we know how to build an energy efficient shell. So at that point, once you get your heating and cooling load down pretty low, you discover that things like hot water and lighting and general plug loads are really taking up a much larger percentage of your house. So you really have to focus on all those other incidentals. And I think that's it for me. So let's turn it over to Emily.
Are we still good on time, Heather? I can crack through this.
Oh yeah, I'm sorry. I talked for a long time.
No, that's totally fine.
Absolutely.
I was kind of hoping I didn't have to talk, but
we're going until 7:30, so we have 35 minutes to finish up presentation and allow for Q&A.
Okay, no problem. I can crack through the slides. So this was just back to the pretty good house. If you think you built a pretty good house, Dan will send you a sticker. that's how you get pretty good house certified. So next.
Don't forget the $5.
Oh yeah, you got to send in $5. They'll send you a sticker. We are writing a book, in case anybody didn't tell you. We're turning the Pretty Good House, which is these fun webinars that we do, lots of articles that Dan and Mike have written over the years, and the website into a more detailed book. So the book will be out in the spring, so stay tuned for that. Just really expands on everything that Mike and Dan went through today. Including case studies, which is what I get to talk about. So there'll be lots of fun case studies in the book, so you can see what other people have done to create Pretty Good House. Next. This is the website currently, prettygoodhouse.org or .com will get you there. Next. So the Slate Farmhouse, you've seen a picture of this already. Next. The concept here really was to take Pretty Good House and how did we make this into a pretty good house? So the economics of the house, it's 3 bedrooms, 2.5 baths, just under 2,000 square feet for a 4-person family. Livable square footage, once you remove all of the double stud exterior walls, is actually only 1,750. So fitting into that, build only what you actually need to live in the space. Double stud walls, especially here in New England, take up a lot of space. And so you lose anywhere from 10 to 12 inches of wall space. So you really cut down on the livable space to be super comfortable. They have scissor trusses on the top, so we blow in cellulose insulation in our scissor truss. Basement insulation is R23 insulation on the interior surface. We use layer of rigid foam here in this case because it had a basement, and then we framed out our stud walls so that we could use something less toxic in the rest of the stud wall and a lower embodied carbon for the whole building. It has air source heat pumps. There's one on the second floor, one on the first floor, one in the primary bedroom. And we actually have one in the basement. And the one in the basement is really for condensation resistance. It runs at a low level and just helps to make sure that we maintain the moisture content that we want in the house. It does have a wood stove. Welcome to Maine. Getting people to get rid of their wood stoves is darn near impossible. But in consolation to that, this house actually has double pane, double hung windows, which we already knew were going to be leaky, which is actually good for our wood stove because we need a little bit more air to get our wood stove to draft properly and not have indoor air quality issues. But it also is much cooler to sit next to those windows than a triple pane window. And so the homeowner actually fires up the wood stove, opens the second floor windows when they run it, which feels like what you wouldn't do. So we use this as a great example of the fact that you really don't need the wood stove to be super comfortable in a pretty good house. There's a rain screen behind the wood siding. So again, Pretty Good House really focuses on local materials. This is a local wood siding. It's painted over a rain screen. It's double strapped on the bottom layer where the siding is vertical, a single strap on the first layer above the porch. This is mixed media of how we also cut costs. Is a horizontal clapboard is always going to be cheaper than shingles or doing different fancier building materials. And so what we do is we'll mix the style and then we'll paint them the same color so that they feel like they have a relationship to each other. And the blower door test at final inspection was 1.5 ACH 50. So next. This was actually built by teams. We talk a lot about team in Pretty Good House, and it's built by 3 independently female-owned businesses. Myself as the architect, Carrie Luce as our landscape architect, and Patrice Miller Capoletti as our builder. And so the 3 of us have what we call a nesting ground collaborative, which is when the 3 of us work together on a project, we put it together into nesting ground to create these pretty good houses. Next. So this is the site. We like to talk about this because site is important. This was actually a site that was really logged very hard. They left a lot of the slash and everything on the site. And so we wanted to make sure that we gave back to the site that we had by actually only building out the front portion of the lot. And the back portion of the lot, the last 15 acres are actually hiking trails that connect to more hiking trails, but to build super efficient all solar homes on this site so that we could give back to a site that hadn't maybe been treated quite properly. You can see in the top picture, there's actually a little yurt on the site as well. The builder lived in the yurt while we built one of the houses on the site, which was kind of fun for the kids to be running around and outside here. Next. Is another shot of the site. In the Pretty Good House book, we actually talk about challenging sites versus flat sites. This site is actually fairly flat, which is nice, but it has the worst clay soil that you could imagine. Drainage is extremely poor. It was critically important that we worked with Carrie, our landscape architect, to help us manage drainage on this site because it doesn't drain otherwise. So next. Here's the first floor plan. Here you see although we add porches and other exterior things that have both performance goals for blocking out summer sun and letting in as much winter sun in, it's basically a big old square. The more square you can make it, the more efficiently you can make it, the less jogs and bumps and things that are water issues, their energy issues, their air infiltration issues. The first thing that we're always trying to do here is to improve the air infiltration rate, and then insulation and everything on top of that, windows, etc. afterwards. So the other thing that we like to think about in Pretty Good House and that we've talked about is universal design, which is aging in place. Is how is anybody going to use this house now in the future? First floor bedrooms are becoming extremely popular for people who want to age in place in their homes. Next. This is the second floor structure. So in addition to this being a 1,700 square foot house for a 4-bedroom or 4-person family, they actually work from home. So we have a home office loft space on the second floor as well. We like to add dynamics to our houses by vaulting the ceilings on the second floor and shortening the end walls so that we don't actually add a significant amount of extra volume to the house, but that we add character and space to the second floors. So the second floor actually has vaulted ceilings in these spaces. Next. So here are some photos. The one on the right is a rendering of the space. The one on the left is the actual living room with the wood stove. This particular homeowner wanted to bring in a lot of recycled and vintage pieces. She knows a lot of people, so all of these timber beams that are in this structure are actually out of different buildings in Maine. They came to our job site for our solar installer on top of his truck. Some of them came out of an old fraternity house at Mottram, and they stripped and put together a lot of these timbers and used a lot of recycled materials to create the style for the inside of the house. Behind the wood stove is actually an old chalkboard from the schoolhouse. So there's a lot of recycled pieces here, everything from dumpster diving and handed down antiques to things that were just salvaged from going to the landfill. Next. This is a view down looking at the living room from the upstairs office loft. You can see our double hung, double pane windows. This was the last house that we did with double hung, double pane windows for all the reasons that Dan talked about in here, but also too, we have to install waffle shades on all of these windows because after the sun goes down and it's dark in Maine at like 4 o'clock now, it gets chilly to sit next to the window. I mean, it's a poor performing part of the house in any case, but at least sitting next to a triple pane window is much more comfortable. So if you can afford to do it, sometimes it has more to do with comfort than it has to do with the energy performance that you're doing. So that's a consideration that we often talk about in pretty good houses. What's the comfort of being in your space and what do you have to live with or modify to get to that comfort level? You can also see that the connection to outdoors and to nature is another thing. We want to be able to walk out, feel like you're outside. We drop our windowsills really low in our living room spaces. So when you stand in that space, you just feel like you're outside. We have a lot of windows on the south facade. Dan was saying the window is a poor performing section of wall, but the most high performance window you can use is the one you don't put in. So strategically locating them in the right places makes a huge difference. So we really cut down on the number of windows we put on the north side of our house so that we can optimize the ones on the south side, which give us more than just a window to see out of. Next. Here's the fenestration stickers. You can kind of see this is the sticker that comes on the window that tells you the performance of the window. Next. These houses were also panelized. So you can see here, sometimes you get your wall systems brought to you on a truck and you can put them up with a crane. There are several different ways to panelize a house. In theory, stuff that's built in a factory and brought to your job site has a better tolerance, might have a better application for building materials. If you're using something like a unity wall panel, it could come with windows and doors and insulation already installed in it. These were just framed with the exterior WRB at least put on to or water control layer, sorry, as we're changing our terminology, the exterior water control layer put on before it got to the job site. Next. This is just a section. Here you can see the vaulted ceiling and the scissor truss that we had. We also use open web floor joists. So Dan talked a little bit about this in the beginning as your house is a system and getting all of the parts and pieces together and it not being a linear process. If you don't think about where your mechanical is going to go during your design phase, you end up with things that are really terrible, like soffits and chases and all kinds of weird things throughout your house. So we use actually a lot of open web framing so that we can get our mechanical ventilation, which for the most part for us is balanced ventilation, ERB, HRB type stuff, through the house in an easy way to get to all of the different areas. On the left-hand side, you can see the double stud wall where the wall itself is actually separated from each other. It's not touching, it's not built on the same 2x on the bottom, so that we can really get insulation to separate inside from outside and cut down on our thermal bridging. Next. Again, here's some framing. There's another example of the open web floor trusses. So you can see it's super easy to run plumbing and ventilation and all kinds of things through that floor system. We also try to pull our structure all the way to the outside if we can, so that we have a lot more flexible space with our interior walls, open concept, or running something through our sections. Next. This house actually has bathroom fans in the bathrooms. This is a pretty good house. Sometimes you have this, sometimes you don't, depending on where you are. In Maine, it can be argued that you could potentially handle the moisture load in your house in the wintertime with an ERV. This particular house has whisper green bathroom fans. So when you turn them on, they're really quiet. It has the wall mounted air source heat pumps. And it's showing you the exterior water control layer, but also anywhere that you have penetrations that pop out through the house, they are sealed, as well as sealing around all your windows, your doors, your ledger boards, where you put your deck on. It's really important where your tapes and seals go. So next. This is the house under construction. All of the houses in this neighborhood have solar panels. This particular house has 20 panels. And this was, again, one of the things where you make the improvements until it financially doesn't make sense. There is room on this house to put another 10 solar panels onto it. So it runs at near net zero without it. It could be totally net zero with another layer of panels, including potentially a future electric car. This house isn't wired for an electric car because it doesn't have an attached garage, but we often put an attached garage on, wire for electric car, planning for the next future agenda. From the first house to this house, we also learned that although 5-foot deep porch is perfect for where we set our window heights for maximum winter sun and minimal summer sun, 5 feet wasn't quite deep enough for the porch. So this porch actually extends out 8 feet, and there's a fun grate built into the porch so the water drips through that and doesn't destroy the actual porch framing. Next. This is the interior. This particular house had to have a gas range. The homeowner owned a restaurant for 20 years and would not back down on the gas range, and has lived in the house now for 3 years and is pulling it out and putting an induction range in. So I'm just saying, for all of those out there who really, really likes to have a gas range, they think they're a chef, they can't live without it. She had an induction range in the first house that was our test house, and she's pulling this out and putting induction range in because she's not happy with the gas. But we built an oversized hood. We have makeup air for it. When you're putting something like this in a pretty good house, the indoor air quality becomes a critical issue, and it gets a whole lot more complicated for makeup air and making sure that you have good air quality inside the house. But every house should have a range vent hood either way. Also in this photo is salvaged slate sink that they actually took back to Monson and had them refinish. She found it in someone's basement. The original company actually refinished this slate sink, and that's what this house is named after, is this particular sink. So next. More salvage pieces that you can see throughout the house. These are all old barn boards that were reclaimed, turned into a sliding barn door. You can see just into the bathroom, that's actually an old dresser that was refurbished into a vanity space. So old timber beams throughout the house. The stairway, which I don't think shows up in any of the pictures, are actually reclaimed pieces of boards on the stairway with newel posts that came from a salvage shop as well, that were all painted the same color, but they have a totally different style. Next. Reclaimed bricks from a factory. Oh, and there's a detail, so you can see the detail of the porch, but the reclaimed bricks from the factory. This was something that we had to plan ahead. So we dropped the floor. So the floor was actually flush. These are full-size bricks that they laid into this mudroom. And we dropped the floor so the floor would be flush with the bricks between the wood flooring and the brick flooring. So that was just something that we planned during the design to make sure that would happen. But just a bunch of salvaged bricks. The tile guy was more than happy to try something new and different. And this is the grate that's built into the deck framing to extend the length of the deck. Next. Verification. So we build an energy model for all of our houses so that we know what we're building against so that we can test it. This is the energy model breakdown, just the heating costs that come from my Ecotrope model that I built for this house, which gave us a good idea of what it should cost the homeowner to live in this house for the whole year. And the owner verified that it was actually just under what our energy model did after a year's worth of data. So that's pretty exciting because you never know what the climate is going to do from year to year, how much solar you're going to actually produce depending on cloud coverage or snow coverage. And the tile on the right is heart-shaped stones that the owner picked up on beaches along the coast of Maine that the tile guy built into our shower. Next. So the other thing that's really exciting is this is built in a 5-lot subdivision in Cumberland. And so 4 of the 5 owners give us a pretty good idea of what they're doing, but owner occupant behavior really makes a big difference. This particular owner is good about cracking the windows when she runs her wood stove. How you use your house is so totally different. She actually has lived in 2 houses in this subdivision. The first one when her kids were really small, this one when her kids were a lot older. And it's really interesting to see the different occupant behavior between teenagers taking 3 showers a day and her trying to control that with an 80-gallon water heater to, not being able to get her kids to take a shower once a week when they lived in the first house. So owner occupant behavior makes a big difference. There's no such thing as a no maintenance house. So knowing what you need to maintain, when you need to maintain, and how you need to maintain it to live comfortably in your house makes a big difference. And that changes depending on who lives there, the age of who lives there, and different parts of the year. So next, that might be the end. Yeah. So that's the end. The end. Quick walkthrough.
Great. Thank you so much. What a fantastic presentation. We are going to switch to Q&A, and Dan has graciously volunteered to moderate our Q&A. We have so many great questions and we are short on time. So our panelists have also agreed to extend an extra 15 minutes tonight so that we can get to a few additional questions. So I'm going to turn it over to Dan so we can squeeze in as much as possible. And our plan will be to wrap at 7:45. So take it away, Dan.
Okay. So I have been trying to group questions so we could get through it more efficiently. Not surprisingly, the most common question was on cost. People were asking about square foot cost. How much more does it cost to build a pretty good house? That was discussed by Bob in the chat. Faced with a limited budget, what priority order do you devote your funds to? Yeah, cost per square foot. Can it be done affordably under 200,000? Okay, so I'll start and then you guys jump in, I guess. Cost is, it's impossible. It's a very difficult subject to talk about. There's so much of a range, but I will say that the energy efficiency piece of a pretty good house is a relatively trivial percentage of total costs. It should not add a huge amount to the budget. 5 to 10% seems like a reasonable amount. You can build a house very cheaply. You can use whatever, vinyl siding. You can use Formica countertops. I mean, there are reasons not to do those things, but there are plenty of ways. There are plenty of things that cost a lot of money or don't cost a lot of money. And the shell is perhaps the most permanent part of your house is not the place to skimp.
I think the only other thing that I would add to that is it's so important to do air sealing details. If there was one thing that I would say, do a really good job on the air sealing details, which are usually the cheapest thing to do,
Right.
and then build from that.
Yep.
Or yeah, or my 2 cents is people ask me all the time, what does it cost to build a pretty good house? The square foot pricing is it's a terrible way to estimate because it's not consistent and we don't know what's included or what's not, but but I have to answer. So when people ask what a pretty good house costs, I say a high quality house in southern Maine starts somewhere around $250 to $300 a square foot. These days it may be a little bit more, but the key is it's a high quality house. You can choose high quality finishes and skimp on energy stuff, or you can invest in the important things and pare back on non-essential decorative things. And so to me, a pretty good house doesn't have to cost any more than a comparable house. Depends what you're comparing it to.
Yeah.
So,
No, I'm sorry.
oh yeah. So to get to so to build a house for $200,000, yes, you can build a house for $200,000. It'll be very small. It won't include land costs, site development, things like that. I just did an ADU, an accessory dwelling unit, 600 square feet that was around that price. And that's about where you can get for a high quality house, whether it's pretty good or not.
I'd also add that, the cost thing, again, returning to the three-legged stool model, is the best way to control cost is to have the contractor involved in the design phase.
And to control cost is to actually design things during the design phase. The less figure it out in the field, the more likely you'll save money.
Yeah.
Yes. We don't like surprises.
All right. There are a bunch of questions about dehumidification and ventilation. I'm just going to read them quickly. Is maintaining dehumidification levels important to the health of your house? HRV or ERV for New England climate? Foundation wall insulation if we don't want rigid foam? Most efficient way to condition makeup air? Ventilation tactics for high moisture events like long baths or soaking tub? And just interested in speakers' experience and or views on ventilation for a PGH. Who wants to jump on that?
I'll start. The quick answer is Emily's favorite answer. It depends. So there's no one way to do it. But yes, maintaining relatively low humidity is really important for building durability. There's overlap between what people find comfortable and what the house wants, but unfortunately, a lot of people prefer humid environments, and your house doesn't. Your house would be happy with 20% humidity all year long. People find 20% is about the lowest suitable for comfort. But you really want to keep to avoid mold and microbial growth within the house. You really want to keep the house below 50% relative humidity, assuming you're keeping it heated to a standard, plus or minus 70 degrees. And I'll also answer the ERV or HRV. That one definitely depends. The official line by most mechanical engineers and energy people is to use an ERV. An ERV is an energy recovery ventilator, or more accurately, an enthalpy recovery ventilator. It basically transfers some of the moisture in the air as well as the air. So it helps if you've air conditioned your air in the summer, it helps preserve the air conditioning. If you've heated the air in the winter, it helps preserve the heat, or it helps preserve humidity levels. That said, in a tight house, especially when you have like teenagers who like really long showers, or you do a lot of cooking, or maybe you don't operate the ventilation system as often as you should, you can get moisture accumulation. So in some cases, an HRV is actually a better choice, but really you want to work with somebody who knows what they're doing to decide. And this is not just my opinion. This is from talking with a lot of people. There is no clear consensus as to which is better in zone 5 or 6.
Well, and I think what I would add to that is it's really critical. I mean, extremely critical that you actually commission your ventilation systems. That is just a non-negotiable thing, right? So you can put it in, but if it's not drawing the amount of air that you need, whether it's a bath fan and you're above 2 ACH in your house, or whether you're doing balanced and it's an ERV or an HRV, you can't control anything if it's not actually moving the air that you want. And so it's really critical that you do that. Zender is the only one that across the board commissions every single one of their units. If you're going to put in something other than Zender, make sure that you hire a HERS rater or another outside consultant who can come and actually check your supply and exhaust ventilation to make sure that you're getting the adequate amount of air in the locations where you've put it.
And I'll just quickly say on the one about the high moisture one is, put in a bath fan. That's the simplest way. Even with I mean, this is another topic that's much discussed, but I still like putting in a bath fan in addition to the ventilation system. I just want to get that moisture out as quickly as possible. Oh, and also I just want to quickly say before we forget, if people are interested in saving the chat, if you go into the chat at the bottom, you'll see a box with 3 dots. If you click on that, it says save chat and it just saves it as a text file. Okay, so the next subject is about materials. Questions are, how are you measuring embodied energy of the initial build and ongoing operations of your design? Is incorporating recyclable materials an important aspect? Best place to source green products? Ways to use ungraded lumber, hempcrete, and rain screen strategies with wood shingles in coastal high wind locations. And then I saw one just came in on how does the open web floor truss cost in comparison to 11 7/8 TJIs. All right.
I'll pick one because I know George Pennyman, he asked about the rain screen strategy with wood shingles and coastal high wind locations. My standard approach with, well, two ways to do it. The quick and easy is to skimp on the rain screen instead of having a robust thick rain screen, which is the gap between the cladding and the wall itself, usually between the cladding and WRB or water control layer. You can use a dimple mat, or not dimple mat. You can use a, what does Martin Holiday call it? Anyway, you can use a product like Benjamin Obdyke HydroGap that has little plastic nubbins that hold the siding off. That's basically the worst but acceptable rain screen. The next best is to use a spun bonded polyolefin, which is looks like a Brillo pad, Scotch-Brite pad. That's usually a 1/4 inch to 3/8 of an inch thick. That keeps the cladding, in this case shingles, off the house, which lets things dry, lets the cladding dry, which makes it last longer, lets the wall dry without the shingles holding water there. And then the best is what I call the basket house approach, which is you fully vertically strap with 1x3 strapping, and then you horizontally strap every 5 inches, which sounds like a ton of work. It's not quite as, from what I understand from builders, it's not quite as bad as it sounds if you're into rain screens. So those are the three that I've done, and I guess I haven't seen that wind has been a problem. We actually, where I used to work, we actually had some leaking in a wall right on the coast in Harpswell. We stripped the entire shingle wall, added a rain screen, and did it all, and it didn't fix. It turned out the windows were the problem. So that was an expensive lesson, but I'm not sure that there's really a different strategy in my view.
I would say, in terms of like recyclables materials, it's a great idea. Some things you need to be cautious about are what's on those recycled materials, especially a lot of old doors and things might have lead paint on them. or a lot of whatever. You just need to make sure you're aware of what the content is of these old materials. But obviously, the embodied carbon presumably has been paid off already on a lot of these things. Even things like, you can get recycled foam insulation that gets stripped off of old shopping centers if you want to use like an exterior insulation detail. Best place to source green products is Steve Constantino's store.
Absolutely.
Yeah, we are very lucky in Southern Maine to have Performance Building Supply. I would strongly recommend checking them out. Hempcrete, I don't know, it seems like a very cool product. I think wasn't Bob doing some stuff with hempcrete?
Yeah, follow along with Bob Swinburne. He's doing a hempcrete project in Vermont, and I'm sure he'll post all about it. So not a whole lot to report back yet, but
yeah, I haven't done anything with hempcrete yet, but it seems very cool.
Yeah, and in terms of measuring embodied energy, really, embodied energy is sort of that's not the cool term these days. We're more concerned with embodied carbon specifically. They're closely related, but not exactly the same. There are a lot of people developing embodied carbon calculators. It's pretty complicated because just the way things are made and transported and installed varies a lot. So it's really hard to get precise numbers. In general, we're usually just looking at sort of broad brush things, like we know all new foam is high carbon. Some are worse than others, but we have general ideas of like closed cell spray foam is always a very high carbon option. Cellulose insulation is always a very low carbon option, things like that. And then in terms of using ungraded lumber, we're actually really lucky in Maine that there's an exception to the international code that allows us to use visually graded lumber, which means the building inspector just has to see that it looks a lot like what a store-bought 2x4 would look like, and it's allowed to be used. So that's I've got 2 projects going now with all lumber cut from the site, and it's really nice just to cut the wood and put it up.
Okay, so the next subject is kind of a combination of existing houses and buying a pretty good house. The questions are, so this is a reno question. Do you always need to have an energy model and blower door test done to decide how to proceed with house renovations? How do you find a PGH to buy? I am interested in finding out how to make a pretty good house better. And what is the acceptance level across the country for the pretty good house concept? Also a related question on this old house, keeping red squirrels and other pests out.
I don't know what the answer is to how do you find a pretty good house, because we've been able to put HERS ratings and energy data into the MLS for years, but nobody does. So, but asking for the information and hoping that you get the correct information on, utility costs and stuff is a good place to start. You can do HERS ratings before you buy a house, which in some cases gives you the option to add energy improvements to your mortgage, which as long as the improvements that you make your your utility bills cost less, you can, borrow more towards your mortgage. And renovation, that one is such a hard question. It depends, right? How to say it, Mike? On what you have, what you should do, how much embodied carbon you have to add to it to make it better. I mean, in some cases, you're working with something that has very limited ability to get better. And so if your option is to fill your walls with closed cell foam, I would probably say don't bother. So, it really depends on the renovation and what you have, what makes the most sense to have the best practical PGH approach. I think that's a different book.
Yes. Reno is Reno is so hard to make any hard and fast rules with, because you're always having to adapt your approach to whatever the existing conditions are. But obviously, an existing house, as Mike said, now is the worst time to be dumping new carbon into the environment. So with an existing house, you don't need to, it's already, much of that has already been done. So we certainly all do a lot of reno and would recommend, building
Yeah.
new houses should be a last resort.
And incremental improvements as you have to replace parts of the system. If you have to replace the siding, that's a good opportunity to do a better air barrier on the walls. If you have to take off the roof, maybe that's an opportunity for you to do better insulation that's hard to get to. Or, don't replace your windows. That's the last thing you should do.
And the person who asked about always need to have an energy model and blower door test, of course, the answer is no, you don't need to, but following up with what Emily was saying, if you live in a house and you're planning on staying there for a long time, it's great to get an energy model done. Energy modelers are very good at saying, here's what's here's what's going to save the most energy in your house. And then you can use that as a blueprint. You can take their prioritized list of things to do, pick away at them, either entirely, or as Emily said, if you're doing a project, if you have a wall open, you know what to do, right? You know that you want to insulate it to X degree. If you've got a project coming up on the second floor and you've got a first floor wall open, can you run wires? Can you run pipes? All of those kinds of things. So I would say, yes, the greatest value of getting an energy model or an energy audit done up front is it provides you with a blueprint. It provides you with sort of a roadmap for future work.
Yeah. And just to add on to that is they might actually be able to identify something that's really not clearly obvious, but could save you a lot of money. Sometimes there's porch framing that's open to your second floor framing that's making you lose a lot of heat because basically you've made the framing in between your floors outside walls. So sometimes those energy models highlight things that you just can't see. So it can be a really great source. And to add to it, someone just put in there, how about tear down rebuilds in areas? And I quoted a podcast a couple of weeks ago with the deconstruction guy in Vermont, who I wish was in Maine. But if you have to do a tear down rebuild, what can you deconstruct, and can you take a little bit longer, and can you donate some of that stuff to Habitat for Humanity? Maybe there's vinyl siding on it that's only been on for 5 years, but you have to take the house down, but somebody else could use that vinyl siding. So if you have to do a tear down, there are ways to take the materials that you have in that house and potentially be able to reuse them in another project, and can be cabinetry that's not in bad shape, flooring that's not in bad shape, siding. There's lots of materials that can be salvaged. So
we just did a semi tear down where we pulled up this beautiful old pine flooring and used it as the ceiling on one of the porches.
An interesting, or just a response to the question of what is the acceptance level across the country of the pretty good house concept. A couple of funny things is over the 10 plus years it's been out there, I've noticed people in the Midwest do not like the name. They don't get the sort of the subtle humor of the name. I don't know what it is. I love Midwesterners, but just the name often does not work for them. And a lot of super high performance people, like the people really into passive house, call it the good enough house, and they often mean it disparagingly. But I think it's an okay name. That's what it is. It doesn't have to be an Uber house. It's a perfectly good house. In terms of the concept itself, because the concept is super flexible, it's a pretty good house in Florida or Arizona or Colorado or Seattle is not going to look like a pretty good house in Maine. So there's broad acceptance. Once we explain the concept to people, almost everybody says, yeah, I'm into that. On the flip side, but a lot of people, especially like on Green Building Advisor, there are a lot of posts about pretty good house. And a lot of people take our sort of original prescribed energy performance numbers that we actually borrowed from other people, Building Science Corp, and just treat the building, the sort of the airtightness and insulation levels, and to them that's a pretty good house, and that really isn't the intent. That's one aspect, but like a lot of people are building like full ICF houses, which is probably the worst in terms of environmental impact. It's the worst way you could possibly build a new house, but it performs well, so they call it a pretty good house. But in my mind, that is not a pretty good house. But so it has broad acceptance across the country. Whether or not they adhere to what we think of as a pretty good house would be up for debate.
But we'll still take their $5.
We will take their $5. I've got stickers right here if anybody wants one.
All right. So next we have a few questions about foundations. Right up your alley, Mike. And we can talk. You can work in slabs too. One is thoughts on using ICFs for building envelopes in cold climates. I guess we just did that one. We can talk about using it as the foundation. Pros and cons of slab versus basement, and best slab on grade design to keep the house 18 inches above grade.
Yeah,
Mike, I will make you answer those.
I will answer those. So yeah, I just described my thoughts on an ICF envelope. I think above grade ICFs are stupid unless you have very specific requirements, and even then, just don't do it. Below grade, I think ICFs, especially these days, it's really hard to find concrete contractors. Every builder is busy, but concrete guys are just extra busy. So ICFs allow builders to do their own foundations, homeowners to do their own. It's a good system. Like all foam manufacturers, they exaggerate claims, so they don't perform quite as well as they say they do, but they're a pretty good way to build a foundation, especially if it's a crawl space or a slab perimeter only. In general, and I think most of us are usually trying to talk people out of basements. Basements are traditional. And on one hand, if you have a site that's really conducive to a basement, like you're building on a slope, a full basement is even meeting pretty good house requirements, which are just a little bit above code minimum requirements. It's still pretty cheap square footage, but it takes some knowledge to do them properly, and almost everybody does not do them properly. So they're setting themselves up for heat loss and moisture related problems. So in general, I try to do a slab when I can. But because I very rarely get an easy site like Emily's flat sites on clay, even with a slab, I usually have to account for grade change. So in that case, I like what's called the raised slab, or at least that's one word for it. You basically build a perimeter wall, backfill it, compact it, and pour a slab on top. Or even better, if you don't like the idea, if you don't want a finished concrete floor as your finished floor, then a few of us are doing what's called a concrete-free slab, which is you build the perimeter wall and you do all the prep work just like you're going to pour a slab, but instead of putting a slab, you put down either 2 layers of plywood or a layer of 2x4s and a layer of plywood. Really, the concrete there is not doing a whole lot other than holding the foam in place. So it's a very high carbon, expensive way to keep your foam in place when you don't really need it. And I feel like there was something else I was going to say there, but I could talk about foundations all day, so I'll stop there.
Okay. I'm going to sort of bang through a few of these just myself. What is the best heating system? As I said before, we like, we think air source heat pumps are the way to go these days. Not universally, but again, talk to your mechanical contractor. Environmentally friendly siding for homes. We always go to wood first. It's a renewable product. It's got low embodied carbon, blah, blah, blah. Yeah, go ahead.
Or Dan, just a question I get. I really can't think of any clients who haven't asked me if they can have radiant floors. So why would they not want a radiant floor in a pretty good house?
Oh, I'm supposed to answer that question?
Sure.
So a couple of things. One is that radiant floors can often be overkill, right? A pretty good house should not need a lot of heat to keep it warm. And a radiant floor works best when it's sort of a steady output of heat. So it can actually warm your house up a lot more than you need it to. I mean, that's the major reason. It's hard to tamp a radiant system down enough. Here's one maybe for you guys more. Ideal percentage of glazing to wall area ratio. You guys have a number? I mean, it depends on your exposure, obviously.
I mean, the rule of thumb is what, less than 15%, but that's really subjective. And I would say build out an energy model, and it depends on which side of the house it's on, and it depends on exterior shading and overhangs and et cetera, et cetera, et cetera.
It depends.
Yeah,
Right.
yeah. Or for me,
Go ahead.
or just a twist on that is I found that for a facade like a Maine facade to look good, you have to have a really talented designer or get lucky to have a front facade look good with less than 15% glazing. If you're not happy with how your facade looks and you keep adding glazing until you reach 15 to 20%, it almost always just looks better. It's just a funny thing, but just it's pretty consistent.
All right, so we're getting close to wrapping up. There's a few questions about like net zero and passive house and stuff. Somebody says, is net zero a reachable goal of the Pretty Good House? Yes, of course. I mean, you know, any house could be net zero if you add enough PV to it, or if you don't run electricity to it in the first place. Net zero, for those who don't know, is just a term meaning that you produce as much energy on site as you consume over the course of a calendar year. A friend of ours refers to it as an accounting coincidence. Net zero is certainly a worthwhile goal, but there's nothing magical about hitting that number as opposed to hitting some other number. But yes, certainly it is certainly a reachable goal if you want to hit that number.
Yeah. I would say if you did everything else right with your Pretty Good House and you really focused on orientation and the efficiency of the house, it's actually way easier to achieve net zero with a Pretty Good House because you have a smaller footprint, so you have less roof, so you can actually only put fewer panels on the roof. And so, you know, there's a point at which you run out of roof for panels.
And finally, I just say for people who are interested in these discussions, there's two things I'd say. One is make sure you are subscribed to the BS&Beer mailing list. Every week, Mike sends out a notice about what the topic is. They're all archived and on YouTube. And the other thing is Green Building Advisor, which really was huge early on in the discussions about Pretty Good House. You know, every topic we've discussed here tonight has been explored ad nauseum, frankly, on GBA. It's a great resource, and we're lucky to have it. And of course, Heather's magazine.
Thanks, Dan. That's a great segue. So thank you all so much for joining us tonight. And I will just put a plug in for the content on the Green Maine home site. There are lots of articles, including many written by our panelists that dive into a lot of these topics. So that's a great place to check out for content specific to Maine. So thanks everyone for joining us tonight. Thank you to our sponsors, Royal River Heat Pumps, Senecal Construction, and Bath Savings. I want to say a thank you to Rain, who kept everything moving so smoothly behind the scenes. And thanks again for joining us and sharing your expertise with us this evening. We do have a special thank you gift for each of our panelists. Some chocolates from our favorite local chocolatier, Dean Sweets. And also, I know you already received subscriptions to Green and Healthy Maine Homes, but we'll also offer a gift subscription to the recipient of your choice. So we'll follow up to get that information. And we will save the chat and send that out in the follow-up email. As I said, this will be recorded and posted on our website later this week. So if you missed any of it, it can be viewed at greenmainehomes.com. I think that is all. This is the last episode in our fall Home and Energy Chat series, and we'll be announcing our spring 22 series shortly. So we'll be posting that to the website and sending it out in our newsletter. So thanks again, everyone. Have a great evening and enjoy the holidays.